сделаем лабораторию из двух гидросепараторов у нас. По тематике микроалмазы у нас будет один сепаратор на микроалмазы, другой сепаратор, соответственно, минералоиндикаторы. Вот. Но пока вот мы сейчас на микроалмазы настраиваемся, а индикаторная минералогия будет позже. Короче говоря, вот мы сейчас сделали такой вот уголок для производства минеральных концентратов гидросепарационных после электрогидравлического разряда, кимберлитов, предоставленных проб самой крупной алмазной компании мира. Эти пробы совершенно точно содержат микроалмазы. Мы видели уже сразу после вскрытия электрогидравлическим прибором Селфраг ряд алмазов. Проблема, кстати, сразу сказать, была определена с тем, что режимы, которые используются на микроалмазах, не подходят для них в связи с тем, что головки алмазов бьются. Поэтому на сегодняшний момент, значит, те фракции, которые мы получили из того небольшого количества кимберлита, которые мы обработали электрогидравлическим способом, разделены были, значит, при помощи мокрого сетования на ротапе, и мы будем получать эти же самые микроалмазы сейчас в концентрате при помощи гидросепарации. Все это для того, чтобы разработать технологию оценки алмазоносности различного рода объектов алмазоносных, в данном случае кимберлитов, для нашего клиента африканского, по, так сказать, составу этих проб, в частности по наличию микроалмазов. Значит, взяты пробы специально с наличием микроалмазов для того, чтобы, естественно, на 100% получить концентраты, значит, содержащие эти частицы для последующих исследований. That electric hydraulic disaggregation based on the actual device, Selfrag, has to reveal all sorts of different phases, ideally preserved, ideally disaggregated, and we want to prove basically that both methods, electrohydraulic disaggregation plus hydroseparation, would do its best for this kind of job. So we can actually extract micro diamonds and after that separate them in one concentrate from a small amount. We know for sure that the micro diamonds are there because it is a specific sample provided by our colleagues. So we have seen some of the micro diamonds being recovering after EH, so frag. So now we just want to collect as many as we can, make sure that basically we can end up with a very nice concentrate that will then be studying. So here we have that amount of material. You can show it here. Okay, that's the full amount of fraction. We actually have done a little bit of a sample preliminary. So now we pour it into the GST. We call it glass separation tube GST, the part of the hydroseparation device, most important one. And we have special vessels like this, which is more handy and more accurate in terms of loading the stuff into the glass separation tube. So we pour this material from the wider vessel to the smaller vessel, less wide vessel, more professional looking, and then we'll be using that, loading into the glass separation tube. So it's a little bit tricky, but we all know what to do. So far we were successful with many other samples, so it won't be any. We expect that to be also successful in this one. But it's spatula. Oh, okay, I will do that with the hands. It's alright. Okay. Thank you. We'll not be able to fit it in all at the same time, so it will be two batches, just to be more or less efficient. Everything we do inside the tray, so whatever we spill from the mini vessel, it always be reunioned afterwards. It's a little bit more that we can fit in, but we try and do the first batch so that to be sure that we are getting out some nice kimberlite indicator minerals if they're there, or micro diamonds straightforward. So first of all, we spread that through the glass separation tube, the whole amount of material. So it will look dark, basically the same color. It's pretty much the same treatment for any sample. We do not start any separation now, we just spread that amount of sample through the glass separation tube. We have few regimes preset, but we start from the very accurate one. The separation has started already. You see all the light fraction that is coming out of the tube, where basically we address the heavy fraction alone, so we just wait and see what's going on here. So the diamonds are 4 point something gram per centimeter, cubic centimeters, so we do not know exactly the assemblage of all heavies, but I presume they are all in between 3 and 4 grams. So let's see what we are getting out. It's a very narrow size fraction, so the density separation would be efficient here, and it won't be any problem of getting denser minerals out of light fraction minerals. You see that the GST glass separation tube is becoming cleaner. You see that drops of materials going down from the upper part of the GST. The bottom part of the GST has become more bright, which means that we have all KIMs and kimberlite indicator minerals and separate diamonds, hopefully, at the bottom. And the whole tube is coming is becoming brighter and brighter. We increase pressure a little bit to get faster evacuation of all the particles from above. We switch the plate underneath to make sure that whenever we change the regime, we have all different other minerals getting out of the tube. This time we are very accurate, so we don't want to lose any heavies. So the regime is only the one that we've used from the beginning. On the other hand, anytime whenever we want to switch, we also switch the container underneath, so that if there is any difference between the minerals that we're getting out of the tube previously, will be considered under the binocular at any time on the specific vessel. You can see that we have different color distribution. At the bottom we have more light, more bright grains, right? More light color grains, brighter grains. You can also see that basically nothing really stays in the tube. Most of the particles went off the tube, so we can get rid of all that amount of sample from the glass separation tube to treat it as a second batch. Basically right now we are producing two products that are known as preliminary concentrate and tailings 1, according to the method of hydroseparation. So since we have all the same color, but it's bright enough to treat it on the second stage, so we just take that off the stage and evacuate it in a separate vessel. We'll see now if we already have some separation under the binocular. So we stop for now, no grains, and we want to check if we got anything useful at our first product. Let's go and see under the binocular. I think Roger can do that for us, because he is a professional in capturing diamonds, micro diamonds in any product, and of course it's the owner of the material. So let's see what's going on there. Okay, straightforward. We already see a few grains that seems to look like diamond. So these micro diamonds represent a sample of how many grams was there, Roger? Do you remember? Just slightly similar to...
That was maybe 2 grams, 3 grams.
3 grams of a sample. So even the first washing was successful. Not many kimberlite indicators though, maybe some garnets here, but since it's very rich, it's very rich sample in microdiamonds, it can already be indicators for a specific rock that it's diamond bearing kimberlite rocks. It's another one here.
And there's an ilmenite.
It's ilmenite as well, yeah, nicely shaped. So our goal is really to produce the final hydroseparation concentrate with all the micro diamonds in it. So it's just a preliminary concentrate, so we still have to do a lot more washing, and also we have another loading to do. So Roger, what do we see on the screen?
There's a piece of microdiamond there, and you see that the triangular faces reflecting light. That's why they burnt out.
Okay.
That up here looks like a zircon, and that is a garnet.
Which is indicator for kimberlite?
Yes, indicator for kimberlite if it's of a specific color, but the diamond is the best indicator of all.
Perfect.
Yeah.
Okay, so we go and continue now. Oleg will be continuing the process. That's preliminary concentrate only, and we can say already that hydroseparation process is efficient for that specific sample. So we're loading the rest. We had to have 2 batches, but we could have done it in 1 batch, but we decided to make it in 2 batches simply because we wanted to make sure that the process is going all right. We fed it all into the same long glass separation tube now, and we start processing once again. We use the same regime, and first of all we're mixing a little bit the whole amount of material by adding more and less pressure at the same different times. Here's the pressure level we have, almost 1.5 meters up above the surface of the table. So now the separation has started. It's very simple and it works perfectly well because it's a very efficient, very fast and very efficient and very fast for any type of the material, even for very fine grain. That's why it is used for geochron, it's used for diamond indicator minerals, it's used for actual micro diamonds in exploration. You can see that the process is going fast. You already have crystals collecting a different color. It's kimberlite indicator minerals mostly, and hopefully some microdiamonds. That's all to do with preliminary hydroseparation, which is preliminary concentrate production. Now we take this amount that we've just received, we take it off the GST glass separation tube, reject it to, as another portion, we reject it to separate clean vessel. It was very quick and fast. So we have 2 portions now. The first portion is the portion of basically first batch, and the second portion is this portion of the second batch. So we switch off the device, we place the GST back onto its own place. At this stage, and basically we can combine both, and these 2 batches now will be processed on a smaller GST, which is SGST, small GST, to produce final concentrate.
You can see
So
the change in color as well.
yeah, you can see that these are three products here. The first is the tailings one, the second is tailings 2 and preliminary concentrate. So these products were made during some few minutes of that amount of sample. So we now be reprocessing this one, which is last tailings, and we receive, basically we aim to receive using that short GST, we will aim to receive final concentrate and preliminary concentrate. These micro diamonds are very small, so we have to be very accurate, and we don't want to lose any grain. That's why it is done in a very careful manner. So anything you spill, is that the word? Can be returned from below, from the vessel below, back to GST. So this process really, I mean, it's pretty much loading and reloading. Anything else is all automation. So it's operator dependent, the process, only at the stage whenever you load anything into the GST, but mind that anybody can do that, even the student, so the balance, weight balance is always there. So we start the next portion, and this is final concentrate. We use the same regime because we know it's efficient. So we see the same process, but in the shorter glass separation tube, it's easier for grains to come out of the tube because it's shorter, so it doesn't have to go all that long distance. It's just get out of the tube the grain that is lighter than the others. The pressure is water pressure controlled by the special needle valve. So all the process is very accurate. Now we have the separation by density. So here we have to be very careful. We really want to get very clean and very beautiful concentrate with all diamonds in it, micro diamonds. Whenever it was long GST, we may wanted to make it faster, like during a minute, but here it may take longer a little bit. Whenever the color changes, we can switch the regime or can increase the water, but this time we want to make sure that really the whole GST will cleanse up before we change any regime. So we switch vessels under the GST whenever we see that the whole situation with the color of the GST will change. Every time you can monitor what are you getting out of the GST by adding, by placing the other vessel under the GST and basically going and checking it under the binocular. Roger, can you check it please? So we can say that we do not lose particles that are of interest.
Some diamond.
Is it already?
Yeah.
Okay. Alright, so we now know that we are at some point we are losing some very valuable things, so we want to really kind of adjust the regime. We're not sure if it is diamond or not, but since we don't want to lose it, we reject that all amount into the separate vessel, or we change the regime. There are two ways of controlling the flow, as I'm saying. It's controlling it, the water pressure and basically the regime on the software. I suggest that we stop separating and just reloading the whole amount, but that can be done using specific regime on the hydroseparator. Put that all amount back into here. It will be tailings, but then we reprocess these tailings on the different other regime. So I suggest we do the final concentration on this particular amount. We just attain a certain amount of final concentrate to make sure that we still have some coarser particles, indicator minerals and microdiamonds if they're there, and then we change the regime for that rest amount, and then we be more accurate, right? We have to decrease the volume so that we have just the tip from which it's easier to pick things up, because you have hundreds rather than thousands of grains of the same size. It's already different products, so we switch the vessel. seems to be that they all have the same, similar density range. So it's definitely not the flow, but the actual regime that we have to change. So we take the last vessel. It's all products that have to be reunited later on and placed in one container and then processed otherwise with a different regime. So I think we stop with this one and reload and make sure that all the heaviest and all the coarsest and most precious ones are in that amount of sample. It's still too big, but I'm sure
Much lighter.
yeah, much lighter color. So we make sure these are all indicator minerals and also diamonds in it. Okay. Let's see what Roger finds in this.
There's the diamond. See there?
Beautiful diamond, yeah.
Looks like a piece of most probably pyroxene or garnet.
So, немножко удивительно, конечно, что частицы никакие не окатанные, не идеально вскрытые, а все изломанные. И это как раз результат работы электрогидравлики, в отличие от электроимпульса, который на самом деле производит гораздо более аккуратные концентраты после гидросепарации. Сколько микроалмазов видели, к сожалению, они все со сбитыми головками после селфрага.
Large number of zircons, very few
Yes.
of the larger pyroxenes or garnets. And then we have this.
What are these all transparent minerals?
This
Yeah.
most probably olivine.
Olivine, okay, that's why it is heavy.
Yeah.
Okay.
Another little diamond there.
Yeah, I see the diamond. And it is fractured a little bit.
In appearance, a lot of these diamonds seem to be almost multiple.
Oh, maybe.
Okay, and that's some sulfide there. Yeah. Messy.
So these are all microdiamonds, 3 microdiamonds at one field of vision.
It would appear so, yes.
Okay. All right. Do you see that the edges of these microdiamonds are still preserved, or
yes,
you think
they're preserved.
You think?
Yeah. Because
Okay.
I do see little crystal faces popping up which seem to be quite intact.
Oh, okay. On the left, on the right.
Yeah, that one, that one. Very difficult to go from microscope to
Но я
screen.
вижу, что они все поколоты, все поломаны. Все они как кристаллы. Не все есть, но они все вон, они все избиты. Вон они. Okay, so we have 3 different products, 4 even. The preliminary the tailings, last tailings, and then few preliminary concentrates that are produced on the small GST from that specific size fraction of diamond bearing cumulite. So we now try and adjust specific regime for the specific portion of the same product, of the same aliquot, or different aliquots with the same regime, so to get maximum amount of diamonds, or at least get all diamonds in every portion. That's what we'll do. We already had tried it, but we have too much olivine, which is much heavier than the diamond, so we want to do all that separate regime, so make sure that we can still get to the very final diamond bearing product. So we have 3 products and we go one after the other using different regimes. We fetch it into the short GST first, one by one, and we use different regimes to get that out. Before doing anything with it, we want to try these regimes, whether they're efficient. There is another set of regimes here, and we just want to see how high the whole fraction is coming up. And then we see that it's coming up quickly, so we just add a little bit of water. Because we are changing the flow rate, we want to change the bucket. So just quickly see what's on there.
A lot more ilmenite, a lot more heavies. Still a couple of diamonds.
Okay.
Into density differences.
Too close. So we have different products with different mix of different basically particles. Yeah. So we've tried all different regimes and different pressures and found out that basically the whole mineral assemblage, I would say, in the same product has very close density range, and even more, very dense minerals collect together with diamonds. So the only way we can pick up diamonds is manually from the same products. But we at least have several products to monitor now and make sure that every regime corresponds to some specific product, and then we can repeat these regimes whenever we want to do the same sort of concentrate. So that was basically the qualitative test that first of all assures us that we are getting diamonds of the EPD product or EH product, whoever wants to call it EH or EPD. And also it's efficient in terms of separation of micro diamonds from the EPD and EH product, which is very important. We haven't seen much of very crushed material, like not isometric, not nice looking crystals. But yet again, we have to separately study every diamond. We'll have to pick it up and then study it separately to make sure that actual effect of disaggregation happens to be accurate enough to extract micro diamonds. All right, so we have all this indicator mineral in one field of vision, and so we can at least judge that actually we get that concentrated in one product.
Yes.
For hand picking.
Yeah. Yeah, I think the diamonds are more in the preliminary.
Yeah.
What is that?
Where about? Oh yeah.
That is a piece of olivine, it looks to me, that has been etched.
All right.
Yeah. So it's indicated there was came up loose in the pipe. Very much the heavies. Zircon ilmenite mainly. Yeah. Garnets. A little bit of metal from the electrode.
Yes.
Lighter fraction, all the fractured olivine grains from the matrix. There was another pair.
What are these black ones? There's all
mainly ilmenite.
ilmenite.
Yeah.
Oh, okay.
There's another mauve garnet, kimberlite indicator.
Because ilmenite's also you know,
Yes.
kimberlite indicator mineral.
But here this concentrate seems to be majority ilmenite and zircon.
Mm-hmm.
With occasional, I don't know what that one is. Maybe a spinel.
Beautiful. All indicator minerals in one portion, together with microdiamonds. This is actually the final concentrate we have from the whole matter fraction. It's roughly 5 to 10 milligrams of the material that is withholding all the concentrate, which has got all the indicator minerals and microdiamonds in it. So we bring it back to our lab to identify these and make sure that we get those as diamonds, not other minerals, and then we report to client.